In this video I'm going to talk you through how to draw dot and cross diagrams for covalent compounds and elements. It's covalent, so remember that's different to ionic, which shows separate ions. There's a separate video about this. This is just for elements and compounds that contain non-metals only. I suggest before you watch this, if you haven't already, there's a video I've made about what covalent bonding is, why it happens. And in that I do the first example of a covalent dot and cross diagram, which is for fluorine, F2. I'm going to go through some more examples now. They'll get progressively more fun. First one is hydrogen, which is H2. So I'm going to first of all use the periodic table to find out how many electrons each atom has and needs. Hydrogen's in group 1, so each atom has got one electron in its outer shell. And because it's in the first period, the full outer shell would only have 2 electrons in first shell. So they just need one more electron. Okay, so I'm going to draw my atoms overlapped. On all of these, I'm just going to show the outer shells. If you ever wanted to show the other shells as well, you could just follow this method and then at the end draw the inner shells inside, but just outer shells. Draw the electron pairs between the atoms. Now, I don't need more than one because each atom just wants to gain one electron. I'm just going to show one shared pair of electrons. One of these atoms will have dots for electrons, the other will have crosses, so that's my shared pair of electrons. Now I need to fill in the other electrons to make up full outer shells. For this one, this atom on the left has got 2 electrons, so that's a full outer shell. On the right it's also got 2 electrons, so it's also got a full outer shell, so I don't need to put any other electrons in. And now last step I check each atom's got the correct number of crosses and dots. So each hydrogen atom should have brought 1 electron and should have received 1 more. So this one, which will be the crosses, should have brought 1 cross and received 1 dot, and it has. And this one should have brought 1 dot and received 1 cross, and it has. That's a really simple example, H2. Let's do water, H2O. So hydrogen and oxygen, we've talked about hydrogen, they just need to gain 1 electron. Oxygen atoms, group 6, need to get 2 more electrons to get their full outer shell of 8 electrons. Overlap atoms around a central atom. This one we need to have a central atom, so I'll make oxygen a central atom and the 2 hydrogens are going to go around that. Overlap the shells. Okay, now I'm going to draw my electron pairs. Each hydrogen atom needs to gain 1 electron, and the oxygen atom needs to gain 2, so it'll gain 1 electron here and 1 electron here, just by having single shared pairs of electrons in each one. So I'll show the shared pairs of electrons there. Let's say that we're going to use dots for the hydrogen atoms and crosses for the oxygen atom. I need to fill in the other electrons to make up full outer shells. These hydrogen atoms have already got their 2 electrons, so they're fine. The oxygen atom needs a full outer shell of 8 electrons, so I'm going to put in, it's already got 1, 2, 3, 4, so I'm going to put in another 4. Okay, I just need to check it now that each atom's got the correct number of crosses and dots. The hydrogen should have brought 1 dot and received 1 cross, which they have. And the oxygen atom, because it's in group 6, should have brought 6 electrons, so 6 crosses, and received 2 dots. So let's check that. 1, 2, 3, 4, 5, 6 crosses, yep, and 2 dots. So water's done. Okay, moving on to oxygen, O2. We've said that we know that oxygen is going to bring 6 electrons, so it needs, each atom needs 2 more electrons. I'm going to draw those atoms overlapping. There's only one place where they overlap, and at this point they need to gain, each atom needs to gain 2 electrons. So I'm going to show 2 pairs of electrons here. So there's 1 pair of electrons, and there's the second. Okay, now I need to fill in the other electrons to make up full outer shell. So let's go with this one. Let's make this one crosses. It's already got 4 electrons, so it needs another 4. Let's make this oxygen atom dots. It's already got 4 electrons, so let's put in another 4. Last one, check each atom's got the correct number of crosses and dots. It's in group 6, so each atom should have brought 6 of its own electrons and received 2 others. So this one should have 6 crosses and receive 2 dots. 1, 2, 3, 4, 5, 6 crosses, yeah, and it's received 2 dots, so that's good. This one should have brought 6 dots and received 2 crosses, which it has. So that's all done. Carbon dioxide now. Got more than 2 atoms, so I'm going to have a central atom. I'll put carbon in the middle, and I'll put the 2 oxygen atoms on either side of the carbon like that. Again, just doing the outer shells, so let's get those shells overlapping. Let's check the periodic table, see how many electrons each one has. Carbon's in group 4, so it's going to bring 4 electrons, and it needs 4 more electrons to get its full outer shell. First of all, we'll look at the oxygen atoms because they're on the outside. Each oxygen atom is going to bring 6 electrons and needs 2 more. So this oxygen atom here needs 2 electrons from this. So there's going to be 2 bonding pairs of electrons. And this oxygen atom here needs 2 more electrons, so there's going to be 2 bonding pairs here. Okay, now let's fill in the other electrons to make up the full outer shells. So let's make the oxygen atoms crosses. This one's already got 4 electrons, so let's put in another 4 on its outer shell. Same with this one, it's already got 4, so we'll put in another 4. And that means the carbon's got to be dots. And the carbon's already got 1, 2, 3, 4, 5, 6, 7, 8. So I don't need to put any more dots in for carbon, that's already done. Last step, check that each atom's got the correct number of crosses and dots. Okay, let's just check. Oxygen atoms are in group 6, so they should have brought 6 crosses and received 2 dots. So this one's got 1, 2, 3, 4, 5, 6 crosses and 2 dots, so that's good. And this one's got 1, 2, 3, 4, 5, 6 crosses and it's received 2 dots, that's great. Carbon's in group 4, so it should have brought 4 dots and received 4 crosses. Let's check. 1, 2, 3, 4 dots, yeah, and 1, 2, 3, 4 crosses. So carbon dioxide's all good there. Last one I'll do is nitrogen, N2. Just 2 of them, so I'll just draw them with their shells overlapping. Let's look at the periodic table. Group 5, so each atom's going to bring 5 electrons and needs 3 more electrons to get a full outer shell of 8. There's only one place where they overlap, so in this place we need 3 shared pairs of electrons. So I'm going to draw those in. 1, 2, 3. Okay, now let's fill in the other electrons to make up full outer shells. Let's make this one crosses. It's already got 6 electrons, so it just needs 2 more. Let's make this one dots. It's already got 6 electrons, so it just needs 2 more. Now they've got full outer shells. Let's just check that each atom's got the correct number. Because it's in group 5, each nitrogen atom should have 5 electrons and it should have received 3 more. So this one should have got 5 crosses and received 3 dots. Let's count. 1, 2, 3, 4, 5. Yep. And 1, 2, 3 dots. Good. And this nitrogen atom should have got 5 dots and received 3 crosses. 1, 2, 3, 4, 5 dots, and it's received 3 crosses. So that's all good. So those are my dot and cross diagrams, just to show you what these, another way of showing these bonding pairs of electrons. A simple way of drawing molecules is just like that, showing the element symbol and then a line to represent a covalent bond. This is just one shared pair of electrons, so I just draw one line, and we call that a single bond. It's the same between hydrogen and oxygen atoms in water, so I'm just going to draw that. For oxygen, there are 2 shared pairs of electrons, so we draw what's called a double bond, which we show with 2 lines. Carbon dioxide is the same, there's 2 double bonds, so we draw a carbon dioxide molecule like that, and then nitrogen has got 3 shared pairs of electrons, so that is a triple bond, which we show with 3 lines. And that explains why nitrogen is so unreactive, because to react nitrogen we'd need to break that triple bond. It's a triple bond, it's very strong, it takes a lot of energy to break. So there you go, any covalent dot and cross diagram, follow those steps and you'll be able to draw it.